Hello, this is Lazarus at Telecom Tech, where telecom and networking technologies are simply explained. Today we'll be simply explaining the MP-BGP EVPN Layer 3 operation for VXLAN. If you like my content so far and you're interested in seeing more networking and telecom technologies simply explained, then please subscribe now to the channel. And when you do subscribe, make sure to enable notifications like so that you'll be informed of new content. If you like this video, make sure to click that thumbs up button. So far in all the videos we've seen with VXLAN, we've been dealing with enabling layer 2 communication between two hosts on different leaf switches that are connected to the same VNI and consequently have their IP addressing within the same subnet. As you can see here, PC1 and PC2 are on the same subnet, and they're connected to ports on VTEP1 and VTEP2, which correspond to VNI 6501. VXLAN is configured so that these two PCs can communicate with each other on layer 2. In other words, this layer 2 network segment on which these two hosts are connected spans the whole VXLAN infrastructure. But what happens if PC1 and PC2 are on different subnets and on different layer 2 segments? What if they're on different VNIs? If this was simply a case of having these PCs on different VLANs, we would use inter-VLAN routing on a layer 3 switch to establish communication. Or we would use a router on a stick technology. And when I say router on a stick, I don't mean this. But what I do mean is this. This is a trunk that connects to multiple sub-interfaces on the router, where each sub-interface acts as a default gateway for the corresponding VLAN. Now, if you're not sure what inter-VLAN routing is or what router on a stick is, do some research. I'll hopefully have some videos covering these topics in the near future. So we are not working with VLANs now, but we're working with VXLAN and VNIs. So how do you enable communication between two different hosts on a VXLAN topology that belong to two different VNIs? Well, here's one way to do it. To enable inter-VLAN communication, which is essentially what we want, in a VXLAN topology, we have to configure the VTEPs in such a way so that they can perform the required routing. Now, in this video, we'll be examining inter-VNI routing in an environment where we have an MP-BGP EVPN control plane employed. Now, take a look at this diagram. Here I have illustrated the VXLAN topology, and I have included an icon here to represent the internal SVI on this VTEP. We've configured VLAN 12 on this switch, and PC1 is connected to that VLAN. And we have SVI 12 functioning as the default gateway for that VLAN. And PC1 here is set up to be on VNI 6501. Similarly, we have VLAN 13 on VTEP2, and we have the VLAN 13 SVI here acting as the default gateway. PC2 is connected to a port on VLAN 13, and VXLAN is set up where this PC is on VNI 6502. Now, each PC will send their packets that are destined outside of this local subnet to the default gateway. The question is, how does this packet then find its way across the VXLAN fabric to the appropriate VTEP? To achieve this, we need to create what is known as a transit VNI. This is a VNI that is created between the two VTEPs that will carry the transit traffic between those two leaf switches. Now, to do so, we create a new VLAN on each VTEP and a corresponding VNI. Let's use VLAN 1213 for this transit VLAN, and the corresponding transit VNI will be 6500. So how does the communication take place? Well, initially, PC1 sends a packet to the IP address of PC2. It will send this to the default gateway since the destination IP address is outside of the local subnet, and the gateway is the local VLAN 12 SVI. The VTEP does a routing lookup for the destination and uses the VLAN 1213 SVI for routing. The local VTEP does a VXLAN lookup for the destination IP, and it finds that it can get there via the VNI 6500 over the NVE1 interface. The VTEP encapsulates the packet with VXLAN and transmits it over VNI 6500 to VTEP2. The 1213 SVI on VTEP2 will then route the traffic to the VLAN 13 SVI, which is the default router for the subnet of PC2. And finally, the VLAN 13 SVI will send that packet to the destination of PC2. Now, I know that there is some information missing here. And the question is, how is the packet routed from this SVI to this SVI? What are the intervening IP addresses? Well, actually, what's happening here is simple VXLAN encapsulation. The spine portion of the network, which is simply shown here as a cloud, actually has MP-BGP and EVPN configured such that the MAC addresses in the VNIs are shared between VTEPs. The local VTEPs already know how to reach the remote VTEPs based on their VNIs and on the destination IP addresses according to the BGP table that has been populated with each VTEP. Now, if you need to, you can review my video on the introduction to the MP-BGP EVPN operation to learn more about how that works. So the underlying VXLAN mechanisms that are used to allow layer 2 spanning of VNIs across the VXLAN fabric are actually being used in exactly the same way to allow this transit VNI to span the VXLAN fabric and create this bridge, essentially, between the VTEPs in question. It's the same VXLAN mechanisms that are operating here. They simply operate on an additional VNI to get from one VTEP to another. Now, it's interesting to note here that this arrangement only takes place when we use MP-BGP EVPN as the underlying control plane mechanism. There are other ways to deploy it, such as using an external routing device, where you would route traffic outside of the VXLAN fabric, have it routed, and then have it returned to the fabric. Alternatively, another popular method is to use a distributed gateway model, where each VTEP acts as the default gateway for the VNIs it supports. In this solution, we actually configure the SVIs with the same IP addresses across all VTEPs in the fabric. And when we do that, we're essentially using anycast IP addresses. But we'll talk about that more in some upcoming future videos. Now, in the next few videos, I'll be taking a look at the configuration of Layer 2 MP-BGP EVPN, as well as this Layer 3 MP-BGP EVPN configuration on Cisco Nexus switches. For now, I hope you found this video useful, and if you have, please click that thumbs up button. If you'd like me to address other related topics, feel free to let me know in the comments below, and please subscribe to get updates to newly published videos. I'm Lazarus at Telecom Tech. I hope this has been helpful for you, and I'd like to thank you for watching.